Okay, so after dealing with simple machines, it is now time to talk about complex machines. So as time passed, people expected more and more difficult tasks to be completed by machines. The machines therefore had to become more complex, and power sources had to develop to run these complicated machines. So rather than having machines just to lift things or travel things across distances, now we wanted things that, could do more complex things, maybe fill in a few steps, that sort of thing. So over the last 2 centuries, coal, oil, and electricity-powered complicated machines were developed in order to do work in large factories. The Industrial Revolution used these large and complicated machines to mass-produce goods for use by customers. So this is where Henry Ford developed the factory method, where one person would do one thing and then the next person would do the next thing, and they would go passing through a series of things, and that's where the factory method came from. So now, rather than having people doing those little steps, they would have machines to do these things. So the steam engine then moved goods across the countries in a very short time, giving people more and better access to food, clothing, tools, and raw materials than they had previously, and the standard for living then improved. The continual development of new technology has led to our virtual dependence on machines. So now, rather than a steam engine, we're using planes or cars, and now we're ever more dependent on machines. I mean, everybody has a cell phone and feels the need to check it all the time, and that goes to show our dependence. So several simple machines all working together in a system are called a complex machine. And a system is a group of parts that work together to perform a function. A bicycle is a good example of a complex machine because it is a system for moving a person from one particular place to another. Within a bicycle are groups of parts that perform specific functions, such as braking or steering, and these groups of parts are called subsystems. Each subsystem in a complex machine contains a simple machine and usually has just one function. Now, when we look at this diagram of a bike here, we have brakes that use a lever to increase force. You have pedals that act as a lever and increase the force applied to the wheel and axle. The chain transfers the force from the pedals to the gears. We have a wheel and axle, and the gears reduce force or increase force depending upon which way you're using them. So here it shows particularly the gears. So you have the chain reel, the derailleur, the chain, and the crank. Okay, this is what propels us through on a bicycle. So the subsystems of a bike are the wheel and axle, the drivers and gears, the frame and materials, brakes and steering, and the aerodynamic design. Each of these subsystems contain only one simple machine, and it only has one purpose or function. We're going to look more into gears and the driving force that drives a lot of these simple machines in the next few presentations. I hope you enjoyed.